Okay, today we're going to talk about the properties of kites and trapezoids. Kites and trapezoids and a kite. Is a quadrilateral. With exactly two pairs of congruent consecutive sides. Two pairs of congruent consecutive sides. And that diagram would look something like exactly two pairs of congruent consecutive sides. So consecutive sides means they're next to each other. All right, so AB is congruent to AD, and then BC would be congruent to DC. So exactly two pairs of congruent consecutive sides. And the properties of a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. Which means that this segment from B to D is going to intersect the segment from A to C, and it's going to form a 90-degree angle. Now in this kite, if that one angle is 90 degrees, then doesn't that mean all of these angles are 90 degrees? So if all of those angles are 90 degrees, then there's at least four triangles inside of this kite, and all of those triangles are right triangles. And if a quadrilateral is a kite, we're going to say if a quadrilateral is a kite, then its diagonals are perpendicular. Just put a comma there. We'll add to that so I don't have to write this first part again. And exactly one pair of opposite angles are congruent. Exactly one pair of opposite angles are congruent. So if you go back to this diagram, you can kind of see which angles or which opposite angles are going to be congruent. Angle ABC and angle ADC are going to be the angles that are congruent. And it's going to be the angles that are formed by the non-congruent sides. Okay? The angles formed by the non-congruent sides are going to be the one pair of opposite angles. Exactly one pair of opposite angles that are congruent. Take a look at the top of page 441, using properties of kites. Here's a, we'll do an example problem. In kite, EFGH. E, F, G, and H, and the diagonals intersect at J. You're given the measure of FEJ is equal to 25 degrees, and the measure of angle FGJ is 57 degrees. All right, so FEJ, that's right down here. This is 25 degrees. And FGJ, F to G over to J, is 57 degrees. They're asking you to find the measure of GFJ, the measure of JFE, and the measure of GHE. So let's look at GFJ first. GFJ, we're going to make that this blue angle right up here. Now, what will make this a lot easier for you is if you add into this diagram the fact that the diagonals intersect at 90 degrees. So all of these are 90-degree angles, which makes this triangle in the upper right-hand corner a right triangle. Now, if a triangle is a right triangle, then its two acute angles are complementary. And the three of them have to sum 180. So, in order to find JFG, you could take 90 minus 57. And whatever 90 minus 57 is, 33. Okay, so this angle equals 33 degrees, which is right here. Next, you're asked to find the measure of JFE. JFE will make it this pink angle, or purple right up here. JFE. Same concept. It's another right triangle, so its acute angles are complementary. So 90 minus 25 will give you angle JFE. What is it? 65 degrees. So 65 degrees. The third angle that they're asking you to find is GHE. GHE. Right down here on the bottom. Now look, we just said that there's exactly one pair of congruent opposite angles, right? And they are the angles that are formed by the non-congruent sides. So now you're looking for this entire angle. And isn't it going to be congruent to this one up here? that highlighted color, that's a little bit harder to see. So, what is 65 plus 33? 98. So this entire, oh, that's harder to see. So this entire angle down here is 90, how many? 98? 98 degrees. So this GHE would be equal to 65 plus 33, 98 degrees. Everybody all right with that? Any questions? Okay, very good. So page 441, I'm going to talk about a trapezoid next. Right in the middle of the page. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So a quadrilateral with exactly one pair of parallel sides. And put a comma there and put called bases. The non-parallel sides are called legs. Trapezoid, it's got four sides, one pair of parallel sides. So trapezoid ABCD has exactly one pair. So let's call the the horizontal sides. If those are parallel, then this is a trapezoid. The parallel sides are called bases. So you've got a base up top and a base down here on the bottom. Non-parallel sides, those are called legs. So you've got a leg on the right and you got a leg on the left. This trapezoid has two pairs of base angles. Alright, so right here, this is a base angle. And so is this one. Same thing down here on the bottom. You have another pair of base angles. And let's say here that if the legs are congruent, then the trapezoid is isosceles. If the two legs are congruent, if the non-parallel sides are the same length, then the trapezoid is isosceles, and it's called an isosceles trapezoid. Stay. In an isosceles trapezoid, each pair of base angles are congruent. So in an isosceles trapezoid, each pair of base angles are congruent. Yes, sir.
Are like all of them or is like are all the angles the same?
No.
Okay, so just like
Here, right here is the key word, is each. So if the trapezoid is isosceles, then in your picture, the top pair would be congruent, and then the bottom pair would be congruent. But the top won't be congruent to the bottom. If a trapezoid has one pair of congruent base angles, so if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So then it is isosceles. So what they're saying is, you don't need to draw anything, but look, if a trapezoid has one pair of congruent base angles, so if you've got a trapezoid, all right, and these are your parallel sides, if one pair of base angles, if this angle is congruent to this angle, then what they're saying is that these angles will also be congruent. Okay? If you're given that picture, four sides, you're told the top's parallel to the bottom, and these two base angles are congruent, it means that the top base angles are also going to be congruent. And it's also going to mean that the left side is congruent to the right side. Okay? So that little piece of information tells you a lot of other information. And that's what they want you to get out of that property. If one pair of congruent base angles, then the triangle's isosceles. And when it's or the trap is isosceles, and that means the other pair of base angles are congruent and the legs are congruent. And one more property here. Trapezoid is isosceles. If its diagonals are congruent. All right, so look over at page 442, example 3. And you're given a trapezoid. X, Y, W, Z. And you're told that X to W is congruent to Y to Z. And you're told the top's parallel to the bottom. You're also told that angle W is 117. You're asked to find the measure of angle y. So find the measure of angle y. So you've got a quadrilateral with two parallel sides. You know it's a trapezoid, and if the legs are congruent, then it is an isosceles trapezoid. If it's an isosceles trapezoid, then the pairs of base angles are congruent. So angle Z would be 117 degrees. All right? Which means that the sum of these four angles is 360 degrees. So if you take 360 and you subtract 117 and another 117, that leaves you 126 degrees. So you've got 126 degrees left. You've got two base angles. But you know that these base angles are congruent because it's an isosceles trapezoid. So if you take that 126 that's left and you divide it by 2, it'll give you each of those angles, which is 63. So 63 degrees. Angle Y is 63 degrees, and angle X is 63 degrees. Example 3B. In this case, your vertical sides are parallel to each other, and your horizontal sides are congruent to each other. So it's a trapezoid, and if the legs are congruent, then it's an isosceles trapezoid. You're told that R to T, let's see, R, Q, T, and S. P is here in the middle. P is where they intersect. RT is equal to 24.1. Q to P, that's equal to 9.6. And you're asked to find P to S. So now, again, like we just said, that if the legs are congruent, then the trapezoid is an isosceles trapezoid. If it's an isosceles trapezoid, then the diagonals are congruent, which means that Q to S is equal to R to T. So what does RT have to, or I'm sorry, what does Q to S have to equal?
24.1.
Q to S has to equal 24.1. So if you take the 24.1 and you subtract the piece Q to P, right, which is 9.6, what are you left with? 14.9? 24.1 minus 9.6. 14.5. So right here is 14.5. All right, so P to S equals 14.5. Get the idea? Top of page 443. The mid-segment of a trapezoid. Connects the midpoints of the legs. The midpoint, the mid segment of a trapezoid connects the midpoints of the legs. It is parallel to the bases. And the average of their lengths. So if we draw a picture of this, this mid segment, if we call this trapezoid ABCD, the midpoint of side AB would be right about here. We'll call it X. The midpoint of side CD is about here. We'll call it Y. BC is parallel to AD, so we've got a trapezoid. If we connect the midpoints of the legs, the segment would look like this. And it is called the mid segment. It's called the mid segment because it connects two midpoints. So mathematically, the length of XY is going to be equal to one of the bases, which is BC, plus the other base, AD, divided by 2. Because this mid segment is the average length of the two bases. So if you take base 1, add it to base 2, and divide that by 2, it's going to give you the length of the mid segment. And that mid segment is also parallel to the two bases. Simple enough? So in this case, if you were given this piece, AD is 25, and the mid segment is 16.5, and you are asked to find the length of BC. Could you find the length of BC? Just plug it back in, right? So in this case, you would replace the length of the mid segment with 16.5, so 16.5 would equal BC plus AD divided by 2. So you could mathematically, you could multiply both sides by 2, and these 2's would cancel. 16.5 times 2, 33, would equal BC plus 25. Subtract 25 from each side. And 8 would equal BC. So there's the length of your other base. Does anybody have any questions?